where, as I'll talk in more detail, we started exploring GraphQL, we started completely re-looking at our ecosystem, and we wanted to go from a house of products to really one ecosystem where all our product families and accounting, payroll, and payment could just be one cohesive ecosystem, and customers really don't see the difference as they step between them, and thereby lay the need for us to completely reimagine the way we manage our APIs and the experiences on top of it. Just to share what we've done so far, as I get into the details, we really, at this point, started deeply adopting GraphQL. We wrote many of our web widgets and components into React and Relay. We invested heavily into schema authoring and tooling to really scale the usage of GraphQL, both from the services developers as well as from the clients that we built on top of it. As we sort of ended 2018, about 80% of the traffic of QuickBooks application, which is used by across 4 million customers, is on GraphQL, which really translates to more than 100 million calls a day. And as of now, the schema scales around 300 nodes and about 3,000 custom value types. And we have consciously started really adopting to the more latest and greatest within the GraphQL. Now we are moving towards Apollo clients mostly in our clients from Relay. Redux Saga is heavily adopted. And while it started by a couple of big monolithic applications consuming GraphQL, now we have 20 to 30 plus microservices across the organization that serve GraphQL APIs. So we've really come a long way in really a broad adoption of GraphQL in our organization. Just to revisit on the challenges and now start going deeper into our journey of adoption of GraphQL. As I mentioned, we were more of a product with APIs bolted on the side, and there were two distinct set of application APIs that we were managing. This started really growing to a fact that every time a new experience came up, which had a distinct need of a certain unique subset of attributes that it wanted, and just to give context, ours is most of a financial accounting application, so we deal with money in and money out operations, journal ledgers, accounting, managing customers, managing their expenses. So there are a lot, it's not like just one or two concepts, like you would imagine a Twitter or Facebook to have news feed as a concept, or tweets as a concept. We would have probably 50 to 100 concepts or resources that matter as domain objects, right? And to be able to build experience, there are frequently needs there. Hey, I just need these 3 attributes of the customer and these 2 attributes of his references and these 5 attributes of the invoices that were created against that. And as we build the single page application, we've frequently created these snowflake smaller APIs that just serve that need because we wanted to be efficient there. So therein lay the problem of really 600 and steadily growing APIs that were really becoming unmanageable. And not to mention, of course, the challenges around maintaining their versions and making sure they're smoothly adopted across all the mobile and web clients we had. At this point, this was like late 2015 when we really started reimagining our API strategy and said, hey, our accounting product, our payroll product, our payments product, and any other acquisitions that we do, instead of all of them being discrete, isolated set of applications with their own APIs, hey, let's start imagining this as an ecosystem which has one consistent schema that all developers could look at, and that's how we would like to take it out to our third-party developers as well. And we really started evaluating GraphQL as one option. One interesting thing that we did as we did that was that we really started thinking about our APIs as an interconnected graph already, even before we started thinking of GraphQL as a possible query language. What it meant was that all APIs and resources should sort of reference across each other. And I'll show you some visualizations that we now have that will illustrate that. But say, for example, an invoice refers to a customer, a bunch of lines, his shipping address, and many such resources. We don't look at them as discrete attributes, but just as a graph where I can navigate to my associated resources. And what that really meant was that if there was a resource that stepped beyond the boundary of one service or one application, it would be sort of seamless and transparent to the consumer. So when we started thinking about that and started composing a schema, it was like a refreshing thought that when we studied and understood GraphQL, it really fitted in well. And it was encouraging for us to see that even without having started with GraphQL, because we started imagining our APIs and resources as a connected graph, it actually lent itself to gel very well with GraphQL while not being married to it, right? Tomorrow we could actually take that modeling of our graph of APIs to another great technology that comes in, possibly gRPC or protobuf in future, and actually work very well with that. So that's one conscious thing that we did. And then when we started comparing REST with GraphQL, as we were hearing earlier, the differences really come in the fact that every time you think about an API on a REST, you think about that resource for all possible use cases that it serves for ahead of time. And you better have to be informed about it so that you really design the boundaries of that resource well. GraphQL actually flipped it completely open, that you think about your entity or resource for all the attributes and capabilities that it should have as a domain object, but then leave it to the client to see, to decide how much of that would it like to either mutate on or fetch, and that responsibility sort of is taken away at the point of the API design, more to the client of what we wants to. And that really encourages a lot of flexibility and reusability in various ways you can imagine using the same resource in different use cases. So that was a very compelling difference in the philosophy that we thought would work well for us. So we started doing a lot of prototypes and concepts, and one aspect that we really looked at was in accounting or the kind of products we had, we used to work a lot in the context of what we call as a company. So a customer's firm or real life company is what we start as a starting point when we sign up to the product. And within that company, in order to really do their accounting or their money in, money out operations correctly, we work across a bunch of preferences, bunch of settings that we may have taken from the customer as he set up the product or he took the help of his accountant to do that. Now, in order for any particular operation to work well, we would end up fetching a lot of preferences and settings ahead of time so that you could do the corresponding operation correctly. And that clearly led to the overfetch problem. So if I had to really fetch the accounting preferences, I would hit an API that will give me like at sometimes 120 preferences, of which I might want to use 5 or 10 in a given context. So this really fit in well that if in my context I just want 2 preferences, here is how I could describe it very clearly in GraphQL. And we built optimizations even at the service providers in such a way that we were able to actually convey to the provider which are the specific attributes that have been requested. So it was not really necessary for the provider to really build the entire object in return. If that's the case, that's fine. But they could actually just fetch enough as has been requested by the client. So it was there was this nice interaction that could be made possible between the client and servers. We had requirements where we would have the same query span across multiple services, and that was made possible quite easily with the right GraphQL server-side abstractions. We could have the same query fetch across, say, one domain object that would serve the accounting data and another one which will serve the contacts in one GraphQL query, and which would earlier have resulted into multiple XHR calls from my JavaScript client. So looking at some of these early benefits, we really started adopting it in 2 to 3 projects, and this was one of the good learnings that we immediately did not have what I mentioned now, that 80% of our traffic is on QuickBooks, was not what we planned from day one. The first 8 to 12 months was carefully chosen 2 to 3 projects where we really prototyped and experimented and took it to production. One of the important things that we realized for any of such new technology is that there is a completely different level of learning when you put it into production in front of customers. So while we sort of got some things working over the next couple of months, we didn't stop there and just present it to our leaders and execs. We said, hey, let's put it to production and really get data behind how this is working. And that's something I would encourage a lot to all of you, to really take a small use case and take it right to production. So I mentioned a while back that this is the point where we decided that we would not have a separate family of APIs for our third-party apps and another one to be used. We would have one consistent family of APIs, and we'll be eating our own dog food, which means we will use the same APIs that we would expect our third-party apps to use, right? So that we face the problems early on. We face the challenges of performance, usability early on before we expect our third-party apps to do that. And what it also meant was one schema that defines the entire ecosystem cohesively, and there are no duplicate entities, which sometimes allowed us to merge concepts which were duplicated across various domains into one place. This led to a very clear platform vision that we came up with, that hey, while centering our API strategy around GraphQL as a prominent client, we would move from one set of APIs, looking at a graph of our APIs as orchestration, GraphQL as a primary interface that allows clients to shape what APIs they want, build the right set of tooling and consistent practices that any developer should be able to write and get through with their first Hello World program in less than 5 minutes. And that was very critical because we wanted to scale this not for a team of 5 to 10 developers, but eventually for 500 to 1,000 developers and eventually to whole of Intuit. So it was very important to have developer productivity in mind right from day one. And of course, we were embarking on the journey of really breaking down our legacy monolithic applications into smaller services. So we wanted to make sure it stitches together and allows for smaller teams to build these services that serve certain entities and resources into the entire GraphQL schema. I'll talk about a very important construct that we spent a lot of time on, which was variability. This is about, hey, how when we are building global ready apps that work across different geographies and industry types, how do you have the same API express those variations in a clear fashion such that, hey, if I have an invoicing application that works in UK and France and India and US, where the regulations, the tax norms, the kind of data I should show for compliance is significantly different, how do I model one invoice entity or one set of resources that we would be able to convey that variability very clearly? And we found some very interesting ways in which we could do it with GraphQL. So I'll show that to you later. So coming to the tooling and productivity, let me actually see if I can show that to you. So I talked earlier that we started thinking about, I don't expect all of you to read this, so this is more illustrative, but I'll just walk through the important aspects that I'm touching here. So what we said was we adopted JSON schema as a schema language to describe our type system. And as I said, this was before even we adopted GraphQL deeply. So what that meant was that we described the schema of all our resources as JSON schema that allows us more control to annotate, to describe each of the attributes and scalars as well as complex type. And using that as a base, we do a bunch of things with this. The first thing that we do, of course, is that with this we are able to generate the respective GraphQL type system. So GraphQL type system is generated out of a pure JSON schema based reference schema that we have. What we also do alongside of it is, in Intuit, fortunately or unfortunately, most of our backend services are in Java. So it was important for us to make sure that we made the life of our service developers productive to quickly build services against that. So we built up a Java SDK, which is essentially leveraging the GraphQL Java library and extending on top of it, where we gave a very simple abstraction that for every entity, you just come ahead and implement this one interface, which allows you to implement a read list, and a write interaction. And that literally maps to a query, of course, a query to a single node or an edge collection, as well as a mutation on the GraphQL side. So practically, my service developers are isolated from a GraphQL-like construct. I could have the same provider server or a REST response or in future any other API protocol technology while isolating them from the specifics of GraphQL while giving all the information in hand. For example, in my read list call or my read call, if I were to query only 3 attributes out of 10 attributes on my type, I actually give that as an input to this object. So I can actually know that, hey, these are the 3 attributes that have been requested, and if I think that it's more optimal for me to prepare a response with those 3, I can actually do that. So that is one critical thing that we did, that with the same JSON schema, we created the GraphQL type system, we created the Java Pojos, of course, that made us to program against this model, and we created the right providers interfaces that made the implementation of those as drop-dead easy. I don't have to write controllers from the scratch. I don't have to worry about how do I latch them into my Spring Boot app or into my services. I just implement one standard implementation contract, and then I'm good to go. And the third thing, most importantly, that the same schema did for us was to generate effective documentation. Lee earlier mentioned that any of these schema languages come with it the benefit of us not having to worry about manually documenting all of that. So if you could see, we use D3JS to really navigate through the schema, and actually I'm able to really visualize all my relationships and the entire object very clearly. I'll use this one example for all the three. Say I have a subscription entity. I'm able to clearly visualize what are my sub-objects, what are my relationships with all of them very clearly, and I have this all generated out of the schema that I showed. At the same time, the same entity has its GraphQL type system generated, and I could play with Graphql as all of us would do to really play with the queries around that. At the same time, my provider has a subscription provider generated where I just implement the read list. Is that if I have a schema which has, let's say, a type called tax agencies, again, you may not be able to read it, but I'll walk through you. We devised a mechanism where we could latch on a metadata or an object along with the response of data of your object. So for example, if I'm querying my tax agency's name, I can also query a tax agency meta object, which I can ask the question at runtime that, hey, are certain specific attributes of this entity enabled or not? What is their min-max type? What are the enumerations I should follow? And what that allows you to do is, if you could see an example UI form on the right, this is the form the way I rendered it, none of the things here in that would be hard-coded on my UI. I can actually choose what is my filing frequency based on the country I am in. I can choose the reporting method or the installment methods, and these are all responded back by the GraphQL response and not really hard-coded in my UI client. So this is an interesting adaptation or extension we did on GraphQL, where that when we define a schema, we also allow, and while generating the GraphQL type system, we generate a mirror image meta model section in it, which allows us to, for the provider to populate and send back some contextual data that the service is aware of. The service is aware which country you're operating on, what are your preferences, what are your industry types, and it absolves the client to have hard-coded checks like, hey, if my country is UK or France or India, then enable this attribute or disable this. It completely makes it very clean. It just makes this one GraphQL request, which gives me data, which is the actual data. Say my account number is 123, that's data, as well as corresponding metadata that allows me to adapt myself dynamically. And that really sort of worked very well for us. And the way we could give the clients complete control that I can query just about enough data. Likewise, I could query just about enough metadata based on the use case I have. And that really made the clients use both of them well together. So coming to some of the other lessons learned as we sort of went through this journey, I think one of the things that we attempted to do, which we in hindsight thought was a mistake, was that we sat down and said, hey, let's actually extrapolate and think about all the resources or all the entities that we need in our ecosystem and model them on GraphQL. And then we went ahead and actually put a lot more things that we were not going to implement immediately, but would come in the future. And that over-design right up front actually did not really work well, because there were a lot, when GraphQL being such loosely typed and flexible type system, where the clients can choose what they want to query, there could be a possibility that, hey, you have exposed these 15, 20 attributes on your schema, and you've implemented only 5 of them. The client may choose to query any of the others. So it becomes a little ambiguous to really say which of the ones are actually returning values or which are returning null or not supported. The learning was just program enough, just design your APIs enough for what your immediate needs are. Make them extensible and flexible, but don't add a lot of attributes. You can always add something, but on an API, it's always harder to remove, and it equally applies to GraphQL, and in fact, more so because the clients are in control. Go beyond a single client, which effectively means that when you're thinking about your resources and entities, think about at least more than one kind of a client that may query the same resource, right? Think about a web client, think about a mobile client. In today's world, think about a conversational client or agents or support, which may be querying that through their kind of tools. And that really gives you a very different perspective of how should you think about modeling your resources and what possible combination of different GraphQL queries may these different actors choose to express. And it also makes your, your testing across them pretty effective. On that note, I would really encourage those of you who will be here tomorrow to attend a talk of one of my colleagues, Peter Thomas, who has written an open source framework called Karate for API testing. And that really has a lot of effective tools and ways to test GraphQL. One of the challenges is that likes of testing, a REST API where, I can use a TestNG or JUnit or any of the other testing frameworks where I can just produce an object and send it out. GraphQL being dynamic, it's great when I'm using a graphical editor or, composing a fragment and putting it in my JSX. But when I have to test it, how do I programmatically compose all different varieties of templates that I have in GraphQL? It becomes tedious if you're doing it just as string manipulations. So Karate gave a lot of interesting templating options that makes automated testing on GraphQL quite simple. So I really encourage you to go attend that talk. I think I talked about it. The other key aspect that we did is, which I showed in the schema, was that we all know that GraphQL has a standard node interface which has the ID. We took that and extended it to what we call as an entity that gave some of the standard constructs that would apply to any entity, say ID, then created, edited by, modified date, and any other metadata that it applies to all, and that gave us a nice root entity for every domain object to extend from. All business objects that we had in our ecosystem we think about them as nouns. We avoid creating resources that are verbs in itself. We can always define custom operations that I talked about. So I will not have a tax recommendation, like more of an action as an entity. I would have tax as an entity and then model operations on top of it. Fields that are arrays on entities naturally become GraphQL connections. So I get all the support in terms of paging, filtering, and searching on top of it, which GraphQL connections support. So whenever we have an entity that has fields or arrays on it, we should ensure that they get mapped to GraphQL connections. It's always useful to, instead of having a flat resource with lot of attributes right in one depth, it's always useful to organize them as sub-objects. That helps us when we start composing our GraphQL just in terms of manageability and readability, but also could have some interesting side effects. For example, in this case, see in my transaction object, I have subgrouped it as balance, payment, estimate, and so on. So every group, if it is null or if it is not present, it allows me to express my GraphQL fragments in those smaller chunks and makes the whole composability of my GraphQL fragments much better. I'll take a pause here to see if there are questions. Should I invite them now, or I'm around here if you would like to ask anything better. But all right, great. So that's in a nutshell what I wanted to cover. If there are any feedback that you have, here is some of the Twitter and Facebook handles that we use for Intuit India. Feel free to drop a note. You could always share the session feedback on this URL if you would like to. And I'm here available till evening. If there's any ways that I could help those of you who are really embracing and getting onto GraphQL new, I'm here to help talk about it. As well as I look forward to all the other talks today and other members who've been using GraphQL for a long time to really learn from all of you. Thank you so much for the time, and really look forward to that. Good morning to all of you, and a warm welcome to all of you who are visiting Bangalore. I have been a resident of Bangalore for the last 18 years. I've spent all of my life and career here. So welcome to all of you, and hope you are going to enjoy the city. So I'm here today to talk about my experience having been associated with GraphQL pretty much since 2015 when it was first came, and how over the last 3 to 4 years, the product I work for, Intuit Quickbooks, has deeply adopted GraphQL, and like the previous two speakers mentioned, would like to share some of my learnings, challenges, benefits, as well as some lessons learned as a part of this talk. A bit about myself. My name is Rajat. I have been with Intuit for the past 8 years. I have been in the industry for the last 16 years, largely building large-scale web as well as desktop applications. And most recently, I have been a part of the QuickBooks online ecosystem, where I built apps for small businesses, consumers, and accountants, primarily to solve their financial needs. I have been fairly passionate about full-stack development, from microservices, Java, Spring, use of event models like Kafka, and of course, React and GraphQL more lately. A bit about Intuit. Intuit, as I said, is in the business of serving customers who are consumers, small businesses. accountants who serve these small businesses and self-employed people, and largely build financial solutions that help simplify the lives of these customers. Intuit was founded in 1983 in Mountain View, California, and since then we have been spreading over 20 locations. We are about 9,000 odd employees, $6 billion in revenue, and we are serving across 50 million customers across tax products, financial small business solutions, payroll products across the globe. And as Lee just mentioned, most proudly over the last month, we are one of the founding members of the Graphql Foundation that got formed, and we're really committed to get Graphql to keep getting better and encourage its adoption, and that's why I'm here to really participate in this community and see what we can give back. All right, so the agenda I would like to cover is, I'll start with a bit of a journey line of QuickBooks as a product, so I can sort of help put into context the tipping point at which we really evaluated and adopted GraphQL and what was the product's journey before that. A bit of insights in our early adoption of GraphQL. The tooling and productivity that we've built within the organization to really scale it for 500 plus developers across the globe who are now working across this product and using GraphQL. And some of the core concepts and innovations that we have done on top of GraphQL or leveraging some features of GraphQL that I would take probably a couple of examples for the time I have. And then I really conclude with some of the lessons learned and things that we should just watch out for. So starting with the QuickBooks journey line. So QuickBooks, as I said, is a business management accounting product with, of course, capabilities that extend into payroll and timesheet management and allowing the customers to accept payments. And it is primarily, a web-based product with a bunch of ecosystem of third-party apps. It does have a bunch of public APIs around which about 5,000 plus apps integrate to at this point. A bit of the technology journey line, if I look at it, the first instance of QuickBooks came up, as Lee mentioned, at the times when the web really took off. So we had a very popular desktop product in US, and learning from that as the web started springing up, we created a web application, which pretty much is where it was between 2000 to 2008. It was a server-side generated web app, no public APIs. It was only serving US customers, and it had no global presence. The next shift was, say, 2008 to 11, where we started embracing the fact that we would have a lot of other interesting applications that could connect to it. So we created the first, most rudimentary third-party APIs that were just slapped upon this web application to allow some of the other financial applications to connect to QuickBooks. 2012 to 14 was the big renaissance period where we actually revolutionized the product significantly. We translated the server-side app into a single-page app, and thereby came the need for us to also put into place a bunch of custom HTTP APIs. I'll call it not primarily pure REST endpoints, but a bunch of HTTP endpoint that we had to create to really serve these single-page views. And this is the point where we really started gaining momentum and traction in our third-party applications. So that's where we sort of had a whole distinct set of APIs that we produced just for the purpose of third-party consumption, while our internal, while our own web and mobile apps continue to use about 300 plus other custom HTTP endpoints that were not exposed to the third parties. So we typically came into this problem, which many companies that look at third-party consumption as an afterthought in their journey face, is that now we had two suite of APIs. And if I may say, we were not eating our own dog food. The APIs that our own web application consumed were not the ones that the third parties were using, and vice versa. And it led to a huge logistic nightmare to sort of maintain and manage these two family of APIs. That's the point where, as I'll talk in more detail, we started exploring GraphQL. We started completely re-looking at our ecosystem, and we wanted to go from a house of products to really one ecosystem where all our product families and accounting, payroll, and payment could just be one cohesive ecosystem, and customers really don't see the difference as they step between them, and thereby lay the need for us to completely reimagine the way we manage our APIs and the experiences on top of it. Just to share what we've done so far, as I get into the details, we really, at this point, started deeply adopting GraphQL. We wrote many of our web widgets and components into React and Relay. We invested heavily into schema authoring and tooling to really scale the usage of GraphQL, both from the services developers as well as from the clients that we built on top of it. As we sort of ended 2018, about 80% of the traffic of QuickBooks application, which is used by across 4 million customers, is on GraphQL, which really translates to more than 100 million calls a day. And as of now, the schema scales around 300 nodes or about 3,000 custom value types. And we have consciously started really adopting to the more latest and greatest within the GraphQL. Now we are moving towards Apollo clients mostly, in our clients from Relay, Redux, Saga is heavily adopted. And while it started by a couple of big monolithic applications consuming GraphQL, now we have 20 to 30 plus microservices across the organization that serve GraphQL APIs. So we've really come a long way in really a broad adoption of GraphQL in our organization. Just to revisit on the challenges and now start going deeper into our journey of adoption of GraphQL. As I mentioned, we were more of a product with APIs bolted on the side, and there were two distinct set of application APIs that we were managing. This started really growing to a fact that every time a new experience came up, which had a distinct need of a certain unique subset of attributes that it wanted, and just to give context, ours is most of a financial accounting application, so we deal with money in and money out operations, journal ledgers, accounting, managing customers, managing their expenses. So there are it's not like just one or two concepts, like you would imagine a Twitter or Facebook to have newsfeed as a concept, or tweets as a concept. We would have probably 50 to 100 concepts or resources that matter as domain objects, right? And to be able to build experience, there are frequently needs there. Hey, I just need these 3 attributes of the customer and these 2 attributes of his references, and these 5 attributes of the invoices that were created against that. And as we build a single page application, we frequently created these snowflake smaller APIs that just serve that need because we wanted to be efficient there. So therein lay the problem of really 600 and steadily growing APIs that were really becoming unmanageable. And not to mention, of course, the challenges around maintaining their versions and making sure they're smoothly adopted across all the mobile and web clients we had. At this point, this was like late 2015 when we really started reimagining our API strategy and said, hey, our accounting product, our payroll product, our payments product, and any other acquisitions that we do, instead of all of them being discrete, isolated set of applications with their own APIs, hey, let's start imagining this as an ecosystem which has one consistent schema that all developers could look at, and that's how we would like to take it out to our third-party developers as well. And we really started evaluating GraphQL as one option. One interesting thing that we did as we did that was that we really started thinking about our APIs as an interconnected graph already, even before we started thinking of GraphQL as a possible query language. What it meant was that all APIs and resources should sort of reference across each other. And I'll show you some visualizations that we now have that will illustrate that. But say, for example, an invoice refers to a customer, a bunch of lines, his shipping address, and many such resources. We don't look at them as discrete attributes, but just as a graph where I can navigate to my associated resources. And what that really meant was that if there was a resource that stepped beyond the boundary of one service or one application, it would be sort of seamless and transparent to the consumer.